exceptions, right? So what are basically exceptions? Exceptions are nothing but an uncaught or unwanted events that is going to happen which disturbs the normal flow of the program. So that's what we have discussed, the definition of your exceptions. And whenever there is a possibility of raising an exception by the program statements, whatever you're going to write, so we need to catch those particular exceptions. Now we have discussed there are two ways to handle these particular exceptions. One is nothing but using your try catch block, which we have discussed in the previous session. And the other way is you can handle the exceptions using a throws keyword. Okay. So now before we discuss in detail how to make use of your throws keyword, let us try to understand, since in the last class already we have seen how to handle the exception using a try catch block. Now we need to look in order to make sure that whether we have understood the various concepts associated with the try catch block. So today's topic of discussion will be nested, try catch, and finally. So now in order to understand the nested try catch block, okay, I have written few examples here. For example, here, let me consider the first case. I have a try block and I have a catch block. Now the question is this code a valid code? Definitely, yes, it's a valid code, because any exceptions that your try block is going to raise, we are written a catch block in order to handle that particular exception. So definitely it's a valid code. Coming to the next possibility, what you have is you have a try followed by a catch and another type of catch. So in the last class already we have discussed, suppose if your code written inside the try block raises an exception, so you can write a multiple catch blocks. Say this is another exception of E and this is another exception type of, say for example, E. You can have multiple number of catch blocks that can be written, because we don't know what is the type of exception your statement written inside the try will raise. So in order to handle the appropriate exception, we have written more than one catch block to handle it. So that's the reason this is also perfectly fine. Means this is a try block with multiple catch. Third, coming to the third one, here you have written a try block and the associated handling code you have written in the, say for example here, and you can see here catch xe means 2 times you are trying to handle the same exception here, which is not allowed. So in the last class case study, one of the case study, we have seen that you can have the multiple catch blocks, but there should not be duplication of the same, correct? So here the 2 catch blocks are duplication of one another, which is not allowed. Coming to the next one, you have try followed by the catch followed by the finally. So definitely this is perfectly valid. Whatever the resources that are being held up, whatever the resources that in being held up by your try catch block will be released. All those resources will be released in the final block. Okay, suppose say if there are some resources, whatever the statements you have written in the try block, it has held up some of the system resources, it has not released. So when it comes to the final block, all those resources that is being held up either in your try block or catch block can be cleaned up or cleared up using this final block. Okay, you have a try catch and followed by finally, definitely it is acceptable code. Coming to your try and finally, definitely yes, this is acceptable. Reason is whatever the resources your try block has held up, so that will be cleared by your finally block. Coming to the next example, you have a try catch, definitely this is perfectly acceptable code. Now when you come here, you have say try, inside the try you have a catch block, definitely this is acceptable code, and you have a finally here. And when you come to this, suppose say in your code, whenever you are trying to handle, only you have written a try block where you put the statements inside the try block in such a way that the statements which raises an exception you have put in the try block. This is not a valid code. Reason is associated catch block is not there. Whenever you're going to write a try block, at least you should have an associated catch block, or at least you should have an associated finally block. Okay, so that's the reason. Since your try is not having either a catch or finally, it is invalid. Similarly, this one, you have a catch block, but there is no code that is raising the exception. Means there is no try here. Similarly here, Without try and catch, you also cannot have this finally individually. Coming to the next set of examples, you have try, finally, and catch. Definitely, it is not a valid code. Why? Because say try and finally is fine. Whenever it comes to execution of this, it gives you an compilation error telling that catch is there where there is no associated try for this. Catch should be written always with respect to your try. Okay, so that's the reason when it comes to this particular statement, it tells that this you have written a catch in order to handle the exception, but there is nobody who is responsible for raising the exception. That's what basically it gives an error, and so that's the reason this is invalid. Okay. Okay. uh, so the next one which we need to look at out is these particular examples. Okay, so these examples basically tells that, see, yeah, for example, you have a try block. Okay, so you have a try block here. After that, you have some statement here, and then you have a catch block. Means after try, immediate statement should be either a catch statement or a finally. But the here in your case, the immediate statement is system.out.println. So that's the reason it tells that it gives you a compilation error telling that for this try block there is no associated catch block because in between you have written this statement. Similarly, coming to the next sample example, you have try catch is there, but here you have written an extra catch. For this catch, there is no associated try statement is there. That's the reason it's invalid. Similarly, if you look out of this, okay, so finally, so try and catch is perfectly fine. But finally, whenever you write a final block, either it should be associated with a try or catch. But in this case, you have only finally. It's not associated with either a try or catch block. So for that reason, you're going to get the compilation time error. So next one is nothing but, okay, try within the catch is perfectly fine. And for this outer try, this is a catch statement you have written in order to handle the exception that's been raised by the outer catch. This is perfectly fine. Now in this case, you have try. For this inner try, there is no catch statement. So that's the reason it's going to give an error that, okay, there is a catch statement missing for the inner try. You're going to get a compilation time error. So now in this case, I told you that whenever you write finally either should be associated with a catch statement or it should be associated with the try. So in this inner case, what I have finally associated with the try, definitely it's perfectly correct. And for outer try, I have a catch block written in order to handle the particular code, whatever the exception your try statement raises. So in this way, you can see that I have given you a few examples which are not valid and which are valid. Here also you have a try, you have a catch, you have finally. As I told you that finally should always be associated with either the try. See, for this try and catch is perfectly matching. But for this finally, there is no, for inner finally, there is no try or catch that is associated. That's the reason you're going to get the compilation error. Similarly, in this case, try catch is perfectly fine. So now for this finally is holds good for this previous try catch statement. You have written extra finally. For this finally, it tells that this finally method is not associated with any try catch block. That's the reason it's not valid. And similarly here, so inside a try, you are written like this, means to say that whenever you write a try or a catch statement, try and catch statement should be written within the opening and closing brace. Since there is missing opening and closing brace in this example, so you'll get a compilation time error. Similarly here also, try, catch, and finally, the code of try, catch, and finally should be written within the flower bracket. So some of the observation what you can make from here is nothing but, okay, in try catch finally, the order in which you're going to write these statements are very, very important. One thing what we have understood from the previous examples. And whenever you're writing a try, compulsory we should write either a catch or finally. That's what I told you that if you have a try block, okay, where your exceptions will be raised, there is a possibility of raising the exception, then it's compulsory that you need to write either the catch block in order to handle those particular exceptions or a finally block. Otherwise, we're going to get the compilation time error. Okay, try without catch or finally is invalid. This is the error basically you're going to get. So coming to the next one, what we need to discuss is whenever we are writing catch block, compulsory try block must be required. That's what I told you. If some statement is raising an exception, you should have a handling code written for it inside a catch block. So whenever we are writing finally block, compulsory we should write try block. Okay. So whenever a finally is there, at least you should have a try block associated with, or you should have a catch block associated with it. Otherwise, the finally block becomes invalid. So inside try, catch, and finally blocks, as we have seen that, okay, one can be nested between the another. We can write a try inside a catch, or you can write a finally inside a try. Okay. So nesting of those all try, catch, and finally blocks are being perfectly allowed. For try, catch, and finally blocks, as I told you that in the last three examples we have discussed, curly braces are mandatory. So these are some of the observations what we have made, and we have understood what are the various ways in order to nest these three blocks together, that is try, catch, and your finally block. Hope so you have understood this nesting of your try, catch blocks. Now coming to the next topic which we need to discuss is your throw keyword. So let us try to understand what's the need of this particular throw keyword and what is the role basically it plays here. Now, for example, consider I have one example here. Say class E have declared, and this is my main method. I've written some statement here 10 divided by 0. Definitely you know that when I execute this particular program, I'm going to get an error. I'm going to get an error. Or what is the error? I'm going to get a runtime error telling that it's an arithmetic exception divided by 0 is a error what I'm going to get during the runtime. I'm going to get this error. Now, also already we have discussed, correct? How basically this error will be raised? Because whenever your system tries to perform 10 divided by 0, it's an error, or this statement definitely is going to raise an exception. So the statement that raises an exception, in which method we are going to look. So the method in which a statement is raising exception is within the main method. So the main method will create an exception object which contains the exception object will be raised by a main method. Exception object contains three information. The first one is nothing but a name of your exception. Second information what exception object contains is brief description of the expression. And third one is nothing but your basically stack trace, indicating that which method has raised this particular exception object. These three information will be stored as part of the exception object that's being created by your main method. Now, after creating an exception object, your main method calls your JVM and handovers that particular exception object to your JVM. Now, JVM, after handling that exception object to JVM asks the main method, do you have any way of handling this particular exception for the main method? Main method tells that, no, I don't have any option of handling that particular exception. So now what JVM decides is, so abnormally it terminates this particular main method, abnormally it terminates the main method, and the exception object, okay, will be handed over to the default exception handler which your JVM has. Now default exception handler, based upon the information what it is there in the exception of the object that is being raised by your main method, it displays all the information to the console telling that, okay, all the three information, telling what is the name of the exception and brief description of the exception and which method was responsible for generating that particular exception, right? So basically this particular concept already we have discussed with the concept called as your default exception handling. Suppose if nobody is able to handle the exception that's been raised by the program, then by default our JVM handovers that to a default constructor, and your default one which is going to display all those particular information onto the screen. That's what we have discussed in the last class based on this example. Now now basically I can tell that this example displays an exception. Okay, default who will going to display the runtime exception that's been done or raised by this particular program. Your default exception handler will display that information onto the console. Coming to next one is, what's the use of this particular throw keyword? Say what I'm trying to do here is, I'm trying to create an object. What type of object? Arithmetic exception object. Basically, this arithmetic exception is an inbuilt class available in your Java. So it has basically two type of arguments it can take. One is say our parameterized argument, one argument constructor. Another type of constructor what your arithmetic exception class as is no argument constructor. Now, as we know that the purpose of using new keyword is it creates a memory dynamically. So now new operator is used to create a memory for this particular object, whatever you have done. New arithmetic exception means I am creating an object of type arithmetic. Now, what I am trying to do, I am creating an object of type arithmetic. Now, using the keyword called as throw, using a keyword called as throw, what I am trying to do is I am going to hand over this particular exception. I'm going to hand over this particular exception, arithmetic exception, to your JVM. Means programmatically, when I'm writing the program, I am handing over it the raised exception to your JVM. In this case, the exceptions that was being raised was internally handled by your JVM. Okay, internally it was handled by your JVM. But in this case, while writing the program, I am writing the extra statement called as a throw, using which I am handling this particular exception object. I'm handling the exception object, this particular object, to your JVM explicitly. So the main difference what you need to understand from this program to this program here is your exception handling, everything is happening internally. And finally, the exception object is being handed over to your default exception handler, which is part of your JVM. And the default exception handler, what basically default exception handler will do is, okay, so default exception handler will going to display the information present in your exception object, correct? So now, what basically we are going to do here is, okay, so in this case, what I am trying to do is, programmatically as a programmer, I am trying to hand over the exception that is being raised to your JVM explicitly. So that handing over the exception that is explicitly by the programmer to JVM is being done using this particular keyword called as your throw. So that's what you can see here. Creating the exception object and handing over to a JVM is happening internally in this particular case. So in this case, main method is responsible to create the exception object and hand it over to JVM. But here, creating exception object, see, with this statement, we are creating an exception object and we are handling over that exception to your JVM explicitly using a keyword called as your throw. So that's what basically we are trying to do here. Throw keyword is used to hand over the user created. I am trying to create an exception here. I am trying to create an exception here. That created exception, I am handling it to your JVM using this keyword called as a throw. Here, programmer is creating the exception object and handling it to the JVM. So that's the main difference, or that's the basic need of your, use of your keyword called as your throw. Okay. So now, so where do we make use of this throw keyword is, throw keyword is best suitable whenever you want to define the user defined exception or customized exception. So if for user defined exception and customized exception, we can make use of this keyword called as a throw. So now let us try to understand some case studies in order to have a clear knowledge of how throw keyword will work. Now, for example, case number 1 I have. So I have a class test. So static arithmetic exception here, I'm creating a reference for this arithmetic exception class, and new arithmetic expression, I'm creating an object. I'm creating an object. E is pointing to that particular arithmetic exception object. Now public static void main, okay, throw E. So what is E? E is nothing but a reference variable that is pointing to this. Now, whenever I'm going to compile this particular program, I'm going to get an exception error as arithmetic exception, because I have raised an exception using a throw keyword. I am handling this particular exception to your JVM. So based on the whatever object I have created, it gives me as arithmetic exception. Now you see the slight variation of the same program here. Class test I have. Static arithmetic, only reference variable I have created, but I have not created any object and I have assigned. No object is created, but here object is created. I've not created any object, only I've created the reference variable. So now if I create only reference variable without object, by default, my reference variable E will be pointing, my reference variable E will be pointing to null if I don't initialize with an object. So now throw E I am doing. So what does this do throw E? Means I'm handling this particular exception object explicitly to your JVM here also, but the type of exception what gets displayed on the screen is null pointer exception. The reason why I'm getting null pointer exception is I'm not assigned E to any of the object. Only I have declared the reference variable. So this reference variable, whenever I'm going to declare, it will be by default initialized to null. When I tell throw E, it displays a particular exception as null pointer exception because null value is stored as part of your E. Okay, that's the reason specifically I'm going to get the runtime exception as null pointer exception here. Because static variable is equal to null, so in E null is being stored. E refers to null, that's the reason we get null pointer exception. So that's the main difference. What if we create an object? What if we don't create an object? What type of exception will be displayed on the screen? So to show the difference between those two things, this example is being given. So the second case which I want to highlight is after throw statement, we are not allowed to write any statement directly. Otherwise, we get a compilation time error saying unreachable code. So let us take this particular sample example. So class test I have. This is the main method. So system.out.println 10 by 0, definitely this statement will raise me an exception called as arithmetic exception, that is divide by 0 error. Whenever it raises an exception, the statements that are following it will not be executed. Why? Because your program gets terminated at this statement itself. It comes out of the program and it displays the information as divide by 0 or arithmetic exception. But in this case, if you consider, I have a main method. Okay, so I am creating one object, new arithmetic exception E, one object I am creating. Throw that particular object I have given here. So whenever I tell throw is basically we are explicitly or manually we are handing over the exception object manually to the JVM or explicitly to the JVM. We are handling over to it to the JVM. Correct? So now once we are handling over that exception object to your JVM, whatever the statements we write definitely will not get executed. That's the reason if I execute this part of the code, I'll get a compilation time error telling that unreachable code. So in this particular statement, which is the statement that goes unreachable is this one. Why? Because as soon as I handle this exception object to your JVM, definitely your control will not come back to execute the statements that are following your throw statement, right? So this statement goes unreachable. That's the reason I have told you after the throw statement, we are not allowed to write any of the statement directly. Okay, otherwise we get a compilation time error telling that unreachable code. So the third case, what is that we need to understand here? Suppose here, assume that I have a class test, I have a main method. Now I am telling throw. So what is this? What is this? A new test means I am trying to create an object for my class itself. This is my class. I am trying to create an object for my class. Okay, this is class is nothing but a user defined data type. This class is nothing but user defined data type. So for my, I am creating the object for my class and I am trying to handle this particular exception to your JVM, which is not allowed. And here, see what is the variation I've done. Class test extends runtime exception. Runtime exception is nothing but an inbuilt class in your throwable. So my class, child class is trying to extend that. So whatever the methods and whatever the properties your runtime exception has, all the properties are being available to your test class. Now see, throw new test. This is valid. Okay, what's the conclusion that we need to understand from this example? First of all, we can use the throw keyword only for throwable types. What do you mean by throwable types? The exceptions, we have seen the exception hierarchy. So which are the different classes that are present in your throwable class? Which are the classes that are present in your throwable class? Only for those type of exception, you can throw only those type of exception, and you cannot throw the user defined Java object. For example, say if you are trying to use for normal Java object, in this I'm trying to use a normal Java object here, right? So that's the reason we are getting a compilation time error. But here I'm trying to inherit your runtime exception. So all the properties available part of your runtime exception will be definitely available for your test class. Now, if I tell throw new test, definitely now it is applicable. Now this new test, whatever the properties all are available for a runtime exception are available for to this also. So now it tells me exception in thread main at this one, but it gives me a runtime exception, but not the compilation time error. So one thing we need to understand is whenever you are throwing the exception, so the throw keyword is applicable only for the throwable types and not for the normal regular Java objects. Otherwise, it is going to give you a compilation type error. So these are nothing but basically some of the conclusion that we can draw for your throw keyword. So another alternative to handle the exception is nothing but your throws keyword. Okay, throws keyword, how you can handle the exception inside the program what the user is going to write. So first way we have seen that using a try catch block we can handle the exception, and the second way is nothing but using a throws keyword. Okay, so in our program if there is a possibility of raising the checked exception, we have already discussed what are checked exceptions. The exceptions that are being caught by your compiler. Okay, caught by a compiler for the smooth execution of the program is nothing but called as your checked exception. Yes or no? Raising the checked exception, then compulsory we should handle. Suppose if your program whatever you're going to write or whatever the statements you're going to write, if those statements are, if there is a chances that those statement raises a checked exception, then it is compulsory for the programmer to handle those checked exception which your program is supposed to raise it. So we need to compulsory handle that, otherwise we are going to get the compile time error saying that exception, say example XXX must be caught or declared. So if you don't handle the checked exceptions that's been raised by your program, then definitely you're going to get the compilation time error. So how do we handle those checked exception? For example, suppose say this is the program what I have. If I run this particular program, definitely this particular statement, whatever I've written abc.txt will raise an exception, Now, if I know that this particular thing will raise an exception, what should I do as a programmer? Definitely I should I should handle this particular exception. Okay, so how do we handle that particular exception? Either you handle this particular exception using a try catch block, or you need to handle this particular exception using a throws keyword. So already we have seen how to handle using a try catch block. So now in this particular concept, we need to discuss how do you handle this particular exception using a throws keyword. Okay, so the execution of the same, for example, here I have this particular program. Okay, so let me go back here, go here, open the file. Okay, open SA11. See, this is the program what I have. Okay, so let us try to execute this. Okay, Java C SA11 dot Java. Okay, JAVA SA11. See, what is it? Java C SA11 dot SA11. SA11. Control S. Java C SA11. Java. Okay. See here, for example, why it is not giving me any error? Because abc.txt is already present. Now I'll give you some ea.txt. Let me save this. I'll go back here. Okay. See here. Okay. So why it's not giving me an error? Basically, it is trying to create. It is trying to print writer and not print writer. Okay, Control S. Okay, Control S. Let me try to execute now. Okay, because this file is also present here. I try to open some, say, PGP. Control S. Okay, Control S. Go back here. Java C. Okay, it is trying to create this particular file. It is trying to create this particular file, and I'm trying to write some data into it. Okay, one second. Just modify this. I'll show you that. Okay, we'll see the execution in the next class. Okay, thank you.